Hello everyone, welcome to another video tutorial for Hammer. At Hammer, our goal is to build an extremely adaptive flight automation platform for the commercial drone industry. In this video, we're going to look at how you can use Hammer to create 3D models using the double mapping mission available inside Hammer. So let's jump right in. So as you can see, what I've got here is my map centered on essentially what is a church. And it's a top-down view, so you can't really tell, but it's a church that we'd be 3D modeling today. So in this video, we're going to walk you through the steps of how you're going to plan the mission, how you can simulate the mission, make sure all the settings are correctly set up, and go out there and fly. And then after the video, we'll also show you what some of the results look like, so you can sort of compare your results and see what are the different changes you need to make to get really good data for a 3D model. So let's begin. So to start making a 3D model mission, what you need to first do is go into the missions menu. So if you tap on the plus button on the top right corner of the screen, it's going to bring you to the missions menu. And there you can see all the different missions that are currently available in Hammer. So we've got everything from inspection to search to mapping. But the mission we're really interested in today is the double mapping mission. So this mission is really useful for creating 3D models, as it allows you to create a double grid pattern which has enough parallax error, and you can later on use structure from motion techniques and data processing software to create a really good 3D model. So for this mission, I'm going to tap on the double mapping mission. And once I've done that, Hammer is going to ask me to tap to draw a polygon over the area I'd like to create a 3D model of. So since I want to capture this area, that's what I'm going to use in my 3D model. So let's say for the purpose of this flight, I want to capture this area. So I'm going to start tapping, and you will notice that points start appearing on the screen. And basically, as I create the model, as I create the polygon, Hammer keeps drawing them for me. So once I've drawn a rough polygon, I can press the OK button over there. And once I do that, Hammer's going to generate a default flight plan. So before we go into setting all the parameters for the flight plan, I think it's important to adjust the polygon a little bit so that it fits the church much better and in a much better fashion. So let's just quickly tap on the vertices and long press and drag so that we can cover the church properly. And once we've done that for all the vertices, then our polygon's going to look much better. So there you go. Let me just drag that one there too. So now we're making sure we're covering enough of the church for a good 3D model, and we're going to now go in and configure all the parameters. So to configure all the parameters of the mission, what you've got to tap is this little gear over here. So every mission will have a gear attached to it, which is a white gear on one of the mission vertices, and when you tap on that gear, it's going to bring up a missions menu. So those menus already got some default parameters which can be changed so that you can plan the flight according to your setup. So the first thing is the mission type, and that's basically telling you what type of mission it is. It already says that drone collects data for 3D models. That's just to make sure that you are in the correct mission. The second setting we have over here is essentially the camera type. So this is basically the camera you're going to fly with in your mission. So at the moment we don't have a drone attached. We're indoors and we're simply planning the flight. But we already know the type of sensor we're going to use to collect the data with. So in this particular flight, I've got Sony A7R selected as my camera. But if you tap on that list, you will notice that Hammer supports a number of different cameras. A lot of them are DJI cameras, but we also support Sony cameras and MicaSense cameras. So you should be able to select the camera you need. And as you change the camera, you'll notice that the flight plan changes ever so slightly, and that's because every camera has a different field of view, a different specification, and therefore you can see different things from a different camera. So I'm going to go for a Phantom 4 Pro camera for this flight, and I'm going to hit done. And once I've done that, I've got my camera set up. The next setting on the list is the altitude parameter. So for the altitude, what you want to make sure is you fly at a safe altitude. So this is absolutely essential. Let's say for the purpose of this flight, we're going to fly at 30 meters. So I'm just going to tap on the altitude label and enter 30. and that's going to make my flight plan more dense. So if I use a slider, you'll see going low in altitude is going to make my flight plan more dense, and as I increase the altitude, the flight plan is going to become more sparse, and that's simply because you can see more at a higher altitude. So let's go for 30 meters for this flight. And by the way, you can easily change meters to feet if you prefer feet. That is possible from the settings menu. So if you tap on the settings menu there is an option you'll find in there to change from meters to feet. Moving on, so ground offset. So this option is really useful for any kind of 3D model or inspection mission for buildings. So essentially what this option says is to include the offset of the building in the flight plan. So what that means is that when you want your drone to collect data, you want to calculate the overlaps not in the plane of the ground, but in the plane of the building. So if the building's at 20 meters height, you'd want to make sure that all your overlap calculations are actually done with respect to the building's height, that is the building's roof, as opposed to the ground. So all the calculations done in the plane of the height of the building as opposed to the ground, so essentially offsetting the ground. So let's say the building's 20 meters. Obviously this can be adjusted on the field to the actual height of the building. So just going to go in and type 20 meters. And once I've done that, you will notice that the flight plan becomes much more dense, because now we're going to be flying at 30 meters altitude from takeoff level. That's important because all DJI drones are actually flying from 30 meters or any meters from the takeoff point. And you'd want to, and over here we've set up the ground offset as 20 meters, which means that effectively our drone will be flying at 30, but looking at the overlap for the height of the building. So it's going to look at 20 meters as this plane in which it's calculating its overlap. So effectively, it's almost as if you were flying at 10 meters, but you're flying at altitude of 30, having an overlap as if you were flying at 10 meters. If that doesn't make sense, please leave us comments in the video, and we'll be happy to illustrate with more visualizations and help you out on this parameter. So the next one on the list is essentially the front overlap. So I guess with the front overlap and the side overlap, we recommend keeping something between 70 to 85% for a 3D model. But obviously changing the overlap will change your flight time and your estimate and how many batteries you use. So we would say you can adjust this to the conditions of your flight, how much time you have, how much batteries you have. You can go for something like 70% in the front overlap, and you can go for 75% in the side overlap. These things are really just things that you sort of understand from experience will be good overlap given the shape profile of the building, but anything between 70 to 85% would be more than enough for any structure for motion software to do the processing later on. So once you set up the side and front overlap, we've got the flight direction, which is essentially the direction in which the drone would fly on this mission. So at the moment, it's very hard to sort of tell the direction of the drone because it's a double grid, and therefore you know that the drone is going to go both one way and then it's going to go orthogonal to it. So, but this just allows us to change the direction of the drone. So at the moment we're not going to start the simulator, which is another feature built into Hammer, which will allow you to see the direction of the drone after you've planned the mission. But let's assume, so one of the things to say is that this flight direction is actually by default along the longest edge of the polygon. So right now 38 degrees is actually representing this particular direction over here. If you'd want to change that to something different, we can obviously rotate, and you will notice the flight plan rotate. So if you're going sort of counterclockwise, you'll see rotating that way, and if you want to go clockwise, then it can rotate that way as well. But for the purposes of minimizing the flight time, we would want to keep it to 38 degrees, which was the default, as that is along the longest edge of the polygon. So that's what we're going to do with the flight direction. The next on the list is gimbal tilt. So this is essentially the pitch angle or the tilt angle of the gimbal. Since we're collecting NIDAR or top-down data for this particular flight, we're going to keep the gimbal at -90 degrees. But let's say you'd wanted to collect oblique angle or slightly tilted photos. You'd want to be able to configure this. So you could configure this to -70 if you wanted to. But for this particular flight, we're going to keep it at -90. To make a 3D model of a building like this, what we would really recommend is to actually do a NIDAR flight in a double mapping mission like this, and then also do a vertical flight using either the vertical inspection option in Hammer or using the tower mapping option also present in Hammer. So, but we're going to go into that later on. Right now, you can keep the gimbal tilt to -90, and that should capture NiDAR photos for us. The next option on the list is the start point number. So this is, so if you look at the map, you will be able to see there is this arrow pointing at the top left corner. If you just move the map here and I zoom in, there is the arrow pointing there, and that's basically the start point of the mission. So the drone is going to fly to this point and is going to start the mission. What you could also do is that, you know, if you were in the middle of a mission, or if you only wanted to capture a certain area, you could change the start point to be something else. So sorry, move to gimbal instead. Let me go back. So if I move the start point, you will see the start arrow jumps on the screen, and that's because the start is actually now at a different point. So you can start from any point in the grid. So that's basically the initial location for the drone. That's potentially more useful in a battery replacement scenario, whereby if you wanted to start from a specific point as opposed to the last remembered point, then you could set that up, and then you could fly the mission with that start point. So not very essential, but useful to know if you're caught in that situation, to be able to start from a custom point. And then we've got 3 more options here. So reversed flight path is essentially if you wanted to start from the other side of the polygon as opposed to the default side that's been programmed in here. So if I tap that, you will notice the start marker jump to the other side of the polygon. That really depends on where you're flying from and what is a better angle for you to view the drone as it starts this mission. So if you're located somewhere down here, then it's better for you to start on this side of the polygon. But if you're located somewhere there as the operator, then it probably is better for you to start on that side. So it really depends on where you're located. It just allows you to have that confidence to see your drone and, you know, keep it in line of sight as it starts the mission, and it helps you to program that in. And last 2 features, they're not going to be super important over here, but essentially smooth corners is a feature that allows you to essentially program in how the drone transitions from one point to the other. It's essentially how it does the turns. If you want the turns to be really smooth as opposed to very sharp, sort of rigid turns, then you need to turn this option on. So if I turn that option on, you will notice that there are all these new green lines that appear on the flight plan. Essentially what they've done is that they've smoothed out the corners for the flight. So every time you fly from one direction to the other and the drone is about to make a turn, it's going to essentially fly almost like a fixed wing and make these smooth transitions. Now, this can be used for a double mapping mission, where the idea is to get a 3D model. If you want to get a really rough model, but if you really want to get precise data, we would recommend keeping this option off. Where the option is really useful is, as the description says, it's useful for LiDAR and magnetometer flights, whereby there is, you know, suspended payload, and momentum breaks in flight are not very good for the suspended payload. So, but for a standard camera like Phantom 4 Pro, which is what we're flying in these flights, we're going to keep that option off. And the final option is terrain awareness. So that's essentially if you were to do, instead of a 3D modeling, if you were doing a more of a mapping mission, and you were doing that on a large site, potentially in hilly terrain, and you'd want the drone to keep a constant distance from the ground, then that option would be useful. But right now we're doing a church building as a 3D model, so this isn't quite relevant. We will make another video specifically on terrain awareness and the number of things to watch out for and how to plan a good mission with terrain awareness involved. But that's going to be later in the series. So that's basically it. So that's how you can configure your mission. And that's the basic setup. So what you'd want to do right after you've set up your mission is you want to hit that button done, and you want to make the menu go away. And right after that, you'd want to be able to start the simulator. So to start the simulator is quite straightforward. So you see the play button over there. You got to make sure that you're not connected to the drone as you do this. And if you're not connected to the drone, press the play button, and Hammer will prompt you that there's no drone connected. Would you like to add a simulator? And if you press OK, Hammer's then going to prompt you to say, well, pick your home location and then tap OK. So let's assume that we're going to fly from somewhere down here. So there seems to be some parking space over here, or a little street going down there. So let's assume we're going to fly from there. If I tap on that a street, I will see a blue icon appear, which tells me that's going to be my home location. And right after that, I can tap the OK button. And once I've done that, you will notice the simulator is going to start up and it's going to show the actual flight for the drone. So I'm going to do that. And yeah, so we've got a drone on the screen and it's going to the start point. It's gone past the start point and now it's started the mission. And basically it's moving along the grid, taking pictures as it goes. This really allows you to have a better idea of what to expect in the field when you go out there and fly, so that you're capturing data most accurately possible, but also in a very safe manner, because everything is quite deterministic and you know exactly what the drone is going to do, what kind of data it will capture. So if you wanted, you could stop the simulator in the middle of the flight. So that's something that will happen in the real drone as well. So if you just press the pause button, the flight would completely stop. You will have then options of whether you want to go home, you want to take manual control, or if you want to resume the mission. So we could do anything we want, but let's imagine a scenario we stopped for a while. We wanted to make sure that the chopper going past, we wanted to sort of give them give them away and sort of just lower our flights, and then we wanted to resume the flight. So if I press the resume button, Hammer's going to ask me if I want to resume. I can press resume, and then the flight will basically continue as planned. The procedure is quite similar for battery replacement as well. So you would, if you wanted to trigger battery replacement very manually, as opposed to waiting for the drone to reach the battery level that it comes back home automatically, you would then press the pause button again, and you would press the go home button, and the drone would climb to the go home height and then basically return home. So as you can see, the simulator is quite a powerful tool, because it allows you to simulate the different scenarios in which you might find yourself and the different actions you might want to take. So it's really good for training purposes as well. And what you can do if you have the simulator turned on is you can go back to our little gear menu over here. You tap that icon, you go back to your settings, and you can change different things around and see how it might affect the simulation. So for example, we might change the start point. So let's say we start the flight somewhere there, and we press the play button, and we will see that actually now the flight is starting in the middle of the grid as opposed to the start point that was planned in the last mission. So we can change a number of different variables here, and we can see what the different outputs are. We can see what the flight would look like, and that allows us to have confidence. So I'm going to pause the flight for a second, and we're going to now look at some of the last settings that you need to configure before we absolutely go out there and fly. So to do those settings, what you need to do is go into your wrench menu over here in the bottom right, and these are the last settings that you need to absolutely program in. So if you tap the button, it's going to open up a menu. So the first set of options are very much map related and the drone type. So this is essentially if you wanted to, when you were planning, you can change your site location. So you can go in air and search, but we've already got the map centered on the church, so I'm not going to go into those details at the moment. Then we've got the max drone speed. So this is quite important, especially for a mapping mission. So what you'd want to do here is you'd want to set the maximum drone speed that the drone is allowed to fly at. We believe that this is the way we've constructed this is that this is essentially just the maximum drone speed that you would allow, and this could be purely for safety reasons. But the speed at which the drone would actually fly will be a speed equal to or lower than this speed. So that speed will be calculated in real time before the flight. The reason for that is there's a number of different variables that Hammer takes into account to find the actual speed that is optimal. So for instance, the camera you have attached might have a trigger interval, so it might be able to take a photo only every 2 seconds. And if that's the case, that really affects what speed we can fly at, so that we don't miss pictures. If we fly too fast and the interval is too slow, we will miss pictures, and we don't want that. Same goes for the exposure speed or the shutter speed of the camera. So if the shutter speed is too slow, we could potentially be missing pictures because we're flying too fast. So Hammer takes all those variables into account, whether it's the shutter speed, it's the maximum flight speed, and also the camera interval, and it figures out what's the optimal speed. It's never going to be more than this speed, so you can comfortably set that, and then Hammer will fly the drone at that speed. Some of the other settings to configure are safety settings. So you'd want to make sure that you have set up your go home height, which is essentially the height the drone would climb to before it returns home. So this should be an altitude that is free of obstructions or any kind of collision possibility. So you would set that to whatever makes sense for the environment. So let's go 50 meters for now. So we're flying at 30 and we're coming back home at 50, so it would rise to 50 meters and then come back home. You will notice that if you push this too far left, a warning pops up, and that is basically saying that one or more missions are higher or within 10 meters of the current go home height. So what we recommend is to keep at least 10-meter offset from the mission height, which is 30 meters here, and the go home height, which has to be higher than the mission. So let's say we make that to 43 or 45 at the moment, and that is obviously higher than the mission height, and therefore the warning goes away. We've also got the go home battery percentage, so that's basically the battery percentage at which the drone will automatically trigger a go home sequence. And a go home sequence is essentially go to the go home height and then fly home in a straight line and then start landing. So it involves those 3 steps, and if you've got 30% battery set up and 45 meters set up for your go home height, what's going to happen at 30% battery, so right now we're at 82, that's because we're in simulation and we can have infinite battery in simulation, but if you're on the field, if the battery went down to 30%, you would notice that the drone would start climbing to 45 meters and then flying back home in a straight line. So those 2 are quite important to set up. And then we've got maximum altitude and radius parameters. So these are essentially just allowing you to use the application based on the country you're operating in. So if your maximum altitude is 120 meters, you can set that as maximum 120 meters, and the drone will never go more than 120 meters. If it is higher for your particular country, obviously we would recommend to make sure that you're following the flying laws in your country and you have the appropriate permissions to fly at a higher altitude. If you have the permissions to fly higher, then you can go all the way to 500 meters, which is what the drone is allowed to go to, the DJI drones at least, and you can even set that as low as 100 meters. The radius is essentially, obviously, the area that the drone can fly in from its home location. So right now it's set to 500 meters, but obviously this could be all the way up to 1 kilometer for you, completely different based on your situation. So you can set it up to as far as 2 kilometers, but obviously we would want to keep it at as close to 500 meters as possible, and it really depends on what flying permissions you have. Last few safety settings that we have is essentially you'd want to configure what action should be triggered once you have a connection loss. So if you lose connection to the drone, let's say it's momentary connection loss, you want to be able to set up the connection. You want to be able to set up the action that's taken in that circumstance. So you could make the drone essentially just continue the mission. So you wouldn't have connection for a few seconds and the drone will continue, and then you can resume the connection. When the connection resumes, you will be able to get the telemetry and you'll know where the drone is and all that. So you can just set up that if you are flying fairly close and you can see the drone at all times. If you're flying slightly far away and you feel more comfortable with the drone just hovering when it loses connection to your remote controller, you can figure that in. Or if you prefer the drone just triggers the go home sequence every time it loses connection, you can configure that too. So it would essentially rise to the go home altitude that we set up there, and it would start returning home. So that's the connection loss action, and you can set that up to as you please. We typically just continue mission as we rarely lose connection, and it just makes the flight more efficient as well. So after that, we've got the go home after mission. So this is just a switch to enable whether or not you want the drone to automatically return or if you want to bring it home manually. So if you switch that on, the drone is going to basically rise to the go home height and then come home. One of the things to take care of is the fact that if your go home location is less than 20 meters away, the drone will essentially not perform the automatic go home sequence and will start landing. So in this case, Hammer does give you a warning. It says, well, the drone is actually only 20 meters away and it's not going to do the go home sequence, so you can bring it home manually. So that's built in as a safety feature. It's not a problem. But this is just to configure whether or not you want the drone to automatically come home. Obstacle avoidance, very important to keep this on. So this is essentially allowing the drone to use its sensors, proximity sensors all over the drone to sense if it's close to an obstacle and then stop abruptly and basically pause the flight. So that's just the inbuilt mechanisms of the drone. So if you want, you can keep them on. I wouldn't. I don't think of I can't think of a scenario where you'd want to keep them off. But unless you're doing very close-up stuff and you're doing manual control flight. So anyway, so that's to turn on and off the obstacle avoidance, and then there is the imperial units. So as you might have noticed, everything in the application is in meters. So you've got the height in meters, distance in meters. Every setting is in meters. But let's say if you are working in a country whereby you prefer feet, so you can just tap that icon and you will notice that everything has now been converted to feet. The altitude is at the altitude for the mission is at 98 feet. And if we press play, restarts, we will notice that even the simulator is now in feet, and we've just got everything in feet now. So if we go into the settings menu, you'll notice that, for instance, the altitude, the ground offset, everything's been converted to feet. So going back to where we were, I'm going to go back to the settings, the wrench settings, and that's it. So that's the imperial units. And then we've got some options over here to import KML files, or to import missions from one device to the other, or export your flight logs. So after you're done flying, you can press that button and you will get your flight logs out in one single folder, everything neatly compressed for you. So you can then put them into your favorite logbook service and track all your flight records. And that's basically it. That's how you would configure your double mapping mission for a 3D model inside Hammer. We do recommend also capturing some oblique photos for this. So for this particular purpose, you would want to be able to use a tower mapping mission. But we've already made a different video on that. So we would recommend checking out our video on tower mapping. So the idea is that once you are done with the double mapping mission, you could then capture some obliques with a vertical inspection or a tower mapping mission. So I'm going to pause this mission right here. I'm going to press the delete button and quickly show you what you could do. And so we've got a drone hovering over there, and we go back to the missions menu as we did from the start of the video, and we can select the tower mapping. So we go into the tower mapping, we can point the center of the building, and we have a new flight plan generated. We go into the settings as before, and we increase the radius of this flight. So the radius of this flight is another setting over here, so that's the flight radius. So we can make that a lot larger so that we're actually flying on the boundary. And we could also increase the object radius. So we could increase the object radius to cover most of the church. And now we've got a different flight plan that is covering the obliques and going up and down in motion. So this is just an aside. It's not directly related to the double mapping mission for 3D models, but this allows you to have vertical oblique pictures that really add more quality to your 3D models, and it also allows that all the textured meshes that are coming out of your models are actually really good on the facade of the building as well. So. If you press done and you press play, you will notice that now the drone is going to perform a tower mapping mission. So in this particular mission, it's going to go around the tower, decrease in height, go around the tower. We made a complete separate video on this. We're going to link that in the description as well, so you can check that out. It's got its own way of configuration, which is very similar to double mapping, but just the parameters are different and specific to that mission. But in a sense, that's how you would capture the obliques. And once you've mastered both of these missions, one of the things to look into is that you can actually do both missions in one flight. So going back to the missions menu, going into double mapping, and drawing a polygon on top of the other polygon, we've now got a double mapping mission combined with a tower mission. So let me change that to 98 feet, which was what we were using before, and that was about 50 feet. So what you can see now is essentially you've got two mission layers. You've got a double mapping mission, and you've got a tower mission. And what you could do is that you could save these two missions separately, or you could have them in the same flight. You could press play right now, and the simulator would combine these missions into one mission. So the idea is that the drone will first do the double mapping mission, so it would do a double grid pattern, collecting all the NIDAR images. And once it's done with that, it's going to then go around the building doing a tower mapping mission. So just to show this quickly, I'm going to increase the speed of the simulation. It's going to tap that button there, and that's going to increase the speed of the simulation. And you can see it's a bit crazy right now, but the drone is essentially doing the double mapping mission, which is going in a crisscross pattern and collecting pictures. And once it's done with that, now I started the tower mission. So I'm going to center this on the map. So you can see the drone's going around the tower capturing all the oblique images. So that's how you could collect really good data for both NIDAR and oblique images, by combining the two missions into one mission. And once you're done with that, the drone's going to finish the mission, arrives to the go home altitude, and then come back home as expected. So that's it for this video. Thanks very much for watching. If you have any questions, please leave them in the comment section, or please feel free to contact us at team@hammermissions.com. We'll leave more description in the content section. Thanks so much for watching, and we'll see you next time.